Okay, measuring angles and arcs. Let's draw an angle right here. Very important thing here. Angle ABC is called a central angle. You will deal with them a lot. Why do you think it's called a central angle?
Because it's in the center.
Teachers and students, before this brief interruption, there's a black Chevy Suburban in the football stadium parking lot. Your lights are on. A black Chevy Suburban parked in the football stadium lot. Your lights are on. Thank you.
Focus. Hey. It's called a central angle because the vertex of the angle is on the center of the circle. That's what makes it a central angle. So I would call this circle B. Let's say it's a 50-degree angle. So everybody understand what a central angle is. Any questions there? Very, very important. Now, label that and do it about like I do. Where's arc XY? Let's just put those all the way up. They don't need to be that close to your ears. Just get them away, get the phone put up. If you remember, guys, I told you I don't want to see phones out. Once you guys start turning a little bit as a class, more homework, I'll let you get those things out again. Where's arc XY? What do you guys think that is? Where would the logic tell you it is? Well, yeah. What? Going from where? From X to what? Here's the thing. I could go from X to Y like this. Does everyone agree? But couldn't I go from X to Y like this as well? Did I satisfy both conditions? The arc from X to Y in both of those pictures? Did I? I did. So, what in the world are we messing with up there? Is that food? Put it up. Put it up. We're not allowed to have food in here. We're sure as heck not going to eat Doritos while we're watching video. One of the loudest foods in the earth. Now, so obviously I'm going to need a way to tell the difference. And here's how we do it. And like I said, I'm doing this because we got to know the basics or we're going to be in trouble. First of all, this right here means arc XY is a minor arc because it has 2 points. Minor arc. Arc XZY is a, what do you think I'm going to word here? Minor in what? Major. Is a major arc because it has how many? 3 points. So, that's how we tell the difference. In almost every case except for one, there's going to be the short way from X to Y, and then there's going to be the what? Long way. The only case where they're the same is when it's an exact semicircle, right? Then it's the same. So the short way you always do with what? 2 letters. The long way you always do with what? So that's how you tell them apart. X, because what I'm saying is I'm going from X to what? Z and then to what? So that middle one could be any point along the long way. The short way, if I just say XY, I'm saying, hey, get there as fast as you can. Think of it like that. If there's a way to help you remember. That makes sense, doesn't it? And these little arcs that go on top of it, that makes sense. Let's call it arc XY, doesn't it? Yes?
If you want to get there as fast as possible, wouldn't you want to use a chord?
Well, I'm talking about when dealing with arcs. Okay? I'm saying you have 2 choices to get from X to Y along the arc. Of course, straightest distance is a straight line. Correct. Now, going back up here to this one, how do I write this? I would say this is the measure of angle what? ABC is equal to what? Can you guys tell me? 50 degrees. That's how I write that up there, right? And don't we measure arcs or angles along a circle? I mean, look at the protractor. Isn't this measured along a circle? So do you think arcs might have degrees as measures as well? The thing is, how are we going to figure out the measure of an arc? Well, it's all based on, guess what? The what? Central angle. So let's say the measure of this central angle is 50 degrees. What's the measure of arc XY? What did I put in front of it? A little m for what? Measure. What do you think is the measure of arc XY? Huh? And you are exactly right. It's the measure of an arc is the same as the central angle that contains that arc. Why do you think I mean contains? It's kind of like it's holding that. It's like it's 2 arms and it's holding it, isn't it? It's holding that small x to y, isn't it? Now, my second question to you guys is, what is the measure of arc XCY? And yes, you have plenty of information. Does everyone agree with him? Disagree? What do you think? Well, how did he get 310? Did he just pick a number? Are you really lucky, or? Right. A whole circle is what? 360 degrees, isn't it? So if from here to here is 50, what's left for this big part to be? A arc's minor arc and major arc should always add up to 360. Easy peasy, right?
It'd be kind of like having one other measurement from the right triangle, and it'll figure out.
Yeah, somewhat. And if you look in the picture here, a semicircle you have to write as a major arc. See, if let's say, I'll use a pencil so I don't, you had one down here, and let's make that E. You can't just say arc AB when it's a semicircle. Why? It's like anything else. Would I know where you were talking about? I wouldn't, would I? I'm saying, okay, are you talking about going under or going on top? You have to say, would have to say ADB or what? AEB. Okay? So that's, remember, with a semicircle. So all the arcs in a circle add up to 360. Got some stuff here. Obviously, these all, when you're doing ones like this, that's 14% of what? If I wanted to ask you what that angle was, what would I do? If I said, what's the other? What's the angle in the other? Can anybody tell me? Right, what is a circle? If I ask you the measure of that angle right there. Well, first tell me how you got it.
360 times 0.1.
A whole circle is 360, right? This is 14% of what? 360 degrees. So to find the measure of this one, I would go change that to a decimal 0.14 times what?
360.
And what do you get?
50.4.
And you do the same thing here. That means that one's 50.4. This one's whatever, 16%, so on and so on. You guys get that? Okay. Adjacent arcs, obviously, it's just like angles. Wouldn't this angle plus this arc plus this arc equal the whole thing? The two smaller parts still equal the whole thing. They just happen to be along a curve now, don't they? Now, how do you label arcs sometimes? If, say, this was 50 degrees, I'd write 50 degrees out there. See how I'm labeling it right there? Now, if this is not a central angle, they're not the same. Okay? Now, arc length. Write this down. Arc length. Is this right here. What is this a formula for?
Circumference.
That's circumference, right? So basically, think of the length of an arc, and that is the distance. If you were standing right here, everybody look up here, and you walked from there to there. That's the length. How far you walked is the length, right? So basically, you're just finding the distance. You know, if you were to take that out, straighten it like a string, and you took a ruler out, that was a string, measured it, how far was it? Well, basically, it's always whatever this angle is, divided by 360, because now you're getting the percentage, right? And then how do we find the distance all the way around? We use what? Circumference. So that's times the circumference. So that's all you do to find the length of an arc. And that's the thing, there's a big difference between length of an arc and what? Measure of an arc. Arc measure is in what? Degrees has to do with the central angle. Everybody gets mixed up on this. Arc length is how far you'd walk if you walked along that arc. So it's a percentage of the whole thing. If this was a 90-degree angle, which I know it doesn't really look like it, wouldn't it be 25% of the whole thing? Because 90 is 1/4. So basically 0.25 times whatever the whole distance is the length, right? You walked a quarter of the distance. So that's all is, even though this, and especially over here with the 2 pi r, because that's the formula, one of the formulas for circumference, isn't it? You could also do what? Pi what? Pi d, right? That's all it is the same as what we did over here and multiplying it times 360, right? It's just we then have to find, okay, what percentage is that of the whole thing? And then multiply it times what? The circumference, okay? Let's get out our red books. Let's do a couple of problems. We still got about, it's 23 after. Would like to get you started by 30 after, so we've still got some time. This section really isn't that bad. Pretty easy. At least I think. Doesn't seem too bad, does it, guys? A lot of times, those sections where we're just learning basic skills in something that's a little bit newer are usually not too bad. Okay, we're supposed to identify whether it's major or minor, and then find its measure. Okay, here's me, guys. This is what I used to always like to do. I used to like to come over here and find everything I could even before I messed over here. Do you guys get, sometimes that's a good thing to do when you've got 6 problems dealing with it. What one jumps out at you that you can find right now? EB? Yeah, there's 180, isn't it? That's 180 because that's a semicircle. I could find these two, the two that are left, if I can just find that one, can I? There's a couple of different ways you can do it. One, are these 2 lines intersecting? So what type of angles are these? Vertical angles, aren't they? What are vertical angles? They are? So if this is 50 degrees, what's this one? The other thing, did that make a straight line? So this plus this plus this has to equal what? 180. That's a diameter, right? So you see how there's different ways. That makes this one what? 130, right? So at this point, I ought to be able to find any of these over here, shouldn't I? Tell whether it's major or minor. First of all, E to A, major or minor? And what's the, what is it? Number 2, C to B, major or minor? And what is it? I like that 50-degree number today, don't I? I didn't even know it was going to be in this one. D to C. What's that, major or minor? What is it? D to E to B. That's D to E and then all the way to B. So that's what? Major. And then I just add them up. 30 and what? 50 is what? 80. And then plus 130 would be? We okay with that? I'm going to kind of stop there because I think we're okay with that, aren't we? All right. This one, P and RQ are diameters. Find the measure. It's the same deal, isn't it? Like I said, if you wanted to, you could come over here. They said PR is the diameter, so if that's 40, and that's 50, what's left for that one to be? 90, and 40 is what? So what's left for this one? 50, because that's a diameter, right? This one's what? That's a diameter, so what's this one? We can find everything here if we just add them up, can't we? UPQ, U to P to Q, so they're talking about that one. What is that? Right, 130. And actually that would be a minor. Anything less than, see, they use 3 right here, and I guess I was wrong kind of when I said that. They're trying to confuse you a little bit. They don't, I guess you don't have to, if you have 3, you know the direction they're going, right? That's actually a minor arc because it's not bigger than what? 180. 180 or bigger. They just decided to use 3 to label a minor arc, so I'm glad they did that so we could realize, they could. You're not wrong, but you should, to me, you should write UQ. Okay? P to Q to R. P to Q to R. What is that? 0.80, isn't it? And they didn't say to say major or minor. I was just make a point. UTS, that's a minor arc, and what is this? UTS.
90.
Easy peasy, right? Okay? Let's go over here. Now we're going to find the length of each arc. This is what I wanted to do. Still, I'm going to go over here and see if I can find everything. That's a diameter, isn't it? So if that's 100, what's that? This and this is what? 110? So what's left for that one? Now I've got everything. I just, on these, when I'm doing things like this, I just think it's always nice to come over here and figure that out. Now, it's just a matter of looking at the picture, isn't it? They want us to find the length of L to M. Length, length, length. This is the one where you find the percentage that this is, LM is, of the whole thing. L to M is what? 100 degrees out of how many? 360. Would you guys agree with that? So that's the percentage or the fraction it is of the whole thing. I'm going to multiply that times the circumference. What'd they say? The radius is what?
5.
So it's going to be 2 times pi times what? 5. Now, how did they ask for their answer? Round to the nearest what? So what am I going to use on my calculator? Am I going to use 3.14 or am I going to use the pi button? Nope. Did they ask me to use 3.14? Only use 3.14 when they what? Tell you specifically to use 3.14. Other than that, they ask you to round, you're using the pi button. So, I'm going to go 100 divided by that. 100 divided by 360 equals that. And I'm going to press times 2 times pi times 5 equals.
113 point.
How about 8.73? I have no idea. I would love to know what I did wrong in the other one. I must have put 3,600 maybe instead of 360. Do you guys notice? I did something goofy. My answer sure wasn't right the first time through. Is that what everybody else got?
I don't know. I'm not sure. Work it out.
Let me see yours. Is it in radians?
I know for our deacon.
Let's just go, with these, I'd put, anytime you do that, I'd go 100, put it in parentheses, divided by 360, close parentheses, just to make sure it doesn't get it on the wrong part, times 2 times, where's your pi button?
Hit the second blue button.
Okay, times 5. Let's see, did you do this?
Yes.
Not quite sure what you did.
I did offset it 360.
Ah, that makes sense. I'm always, whenever I do parentheses, I always like to, when I can see it like that, I put them in parentheses to make sure things don't get messed up. So as you guys can see, this isn't too bad, is it? Let's do one more. Let's go down, what do you say, 18? N to J to K. What percentage of the whole thing is that? Or how many degrees of 360 is that? N to J to K. So 120 over 360. I'm going to multiply that times, and NL equals what? 12 feet. So pay attention. What do they give me? They give me the diameter, or do they give me the radius? So it's just going to be times pi times what? 12. I don't need to do 2 pi r. I can just do pi d, right? If you wanted to, you could turn it and go 2 times pi times 6, but you'll get the same thing. So I'm gonna go 120 divided by 360 equals, it's a third basically, times pi times 12. What'd you guys get? L is equal to 12.57 feet.
Yeah.
The biggest thing, guys, is being able to recognize the difference between the what? Length and what? Measure. Everybody always wants to get those two mixed up. Okay, your assignment is numbers, I think it's 1 through 7 maybe. 1 through 7, and then I wrote it down somewhere here where I thought, well, of course, or 1 through 5, 7 through 23. One through 5, 7 through 23. As always, write problems, draw figures, show all steps and work. Guys, I don't care. I know your circles aren't going to be perfect. Just do your best. Easiest way to do it is get your pen kind of straight up and just quickly do it. That's a good enough circle, you know. You'll get better at it. Okay? Now, if you want to use a quarter, use a quarter. Or, here, I got something. You know, you can use something like that if you want to. All right? Do whatever you want. Okay?